Hey everyone, welcome to Tutoring. Hope you're having a great day. Today we are doing question 12 of chapter 10C. So this is your kinematics chapter. It's on velocity time graphs. This question, in this video, I'm going to be using the velocity time graph concept, but you can also use these four formulas to solve for this question. Okay, so let's have a read. Question 12. Two cars A and B each moving with constant acceleration. The moment you hear constant acceleration, you can use these four formulas, and in terms of your velocity time graphs, your lines would just be linear lines only, so no curves at all. So you got two cars traveling in the same direction along parallel lanes of a divided road, okay, and then when A passes B, so you got two cars over here, A passes B, the speeds are 64 km per hour, so this is the initial velocity, so A is 64 km per hour, and then the initial velocity of B is 48 km per hour. So just write down all the information that you have or given to you, and then let's keep reading. 3 minutes later, okay, there's two important things here. One is they're telling you about the time. So the time is 3 minutes, so t equals to 3, and that's in minutes. Our units for speed was in terms of kilometer per hour, that is not in minutes, so you will have to do some conversion. In this case, I'm going to convert everything into minutes. So if you want to convert 64 km per hour into minutes, this is what you should do. 64, so there's 64 km in 1 hour. In 1 hour, there's 60 minutes. So technically, you can say your speed is 64 km in 60 minutes. And then we want to find it per minute, right? So in 1 minute, how many kilometers did we travel? So you do the ratio, just use the ratio. 64 divided by x equals to 60 divided by 1. X, really, you can flip that, over 64 equals to 1 over 60. That means x equals to 64 divided by 60, and that is in your kilometer per minute. And of course, you can simplify that, 64 divided by 60. So what you should get is 16 on 15. So 16 on 15 kilometer per minute. Do the same thing over here, 48 kilometer per hour. If you want to convert it, well, over here, just use the same concept, use the ratio. It's really just this number right here divided by 60. So 48 divided by 60 is equals to 4 over 5 kilometer per minute. That's simplified, okay? So that's the initial velocity in terms of kilometer per minute. We travel for 3 minutes, and then 3 minutes later, B passes A. So car B started off slower, so it's 48 compared to 64. And then B is going to pass A, traveling at 96. So velocity of B at the end, the final velocity is 96 km per hour. Once again, we're going to convert it into kilometer per minute, and what you should get is 8 over 5 km per minute. Okay, we don't know what velocity of A is. That's a question mark. We're going to have to solve it in part A. See over here, the speed of A. Right, we should draw a velocity time graph to answer these two, but you can also use these four formulas. So let's have a go. Try answering part A. So velocity time graph, gonna draw one up here. Hopefully this is a good one. So velocity as your y-axis, time as your x-axis, and then let's get the lines up. So I'll use green as the velocity, the motion for A, and then red for motion for B. Okay, so A started off higher than B, so maybe up here somewhere, 64, or in this case 16 over 15, 16 over 15 over here, and then we don't know the final velocity. We know it's a constant acceleration, so it's just a linear line. We're just gonna make it go up somewhere here, possibly, right? That's what we know for sure. It's gonna be 3 minutes. It's gonna take us 3 minutes to reach this point. We don't know the velocity. We'll find that soon. Right, so that is for A. You can describe the velocity of A, so VAT, as equals to 16 over 15. That is the initial velocity. So remember, mx plus c will be your initial velocity. And then m, we don't know for sure yet. We'll find that soon when we find the speed of A, and then we'll find the acceleration, which can get us the m, okay? For now, this is just blank. Let's look at B. So the motion for B, we start off at 405, or if you convert it to kilometer per hour, it's a little bit lower than 64, so maybe somewhere here. We'll call that 4 over 5, that's where it starts, and then it ends up at 96 km per hour, 8 over 5 km per minute. We know that B has to eventually be faster than A, because B started off slower, but if you want to catch up to A, the speed has to be higher than A, okay? Or else it doesn't make sense. If you're always slower than A, you're never going to catch up, right? So in this case, we're going to draw a line that's going to go up here possibly. It's not to scale, so excuse my terrible scaling, but this is what it is. The speed is 8/5 kilometer per minute, or 96 kilometer per hour. Right, we can actually find the equation of B, which we will do right now, might as well. So what is the motion or the velocity equation for B? We start off with the initial velocity, so that's 4/5. 4/5, that's the initial, plus the gradient. The gradient is pretty much your acceleration. How do you find acceleration? Well, just take this point right here, minus that point, and then that's pretty much it, right? Your y2 minus y1 over x2 minus y1. So if you want to find the gradient, or in this case the acceleration of B, we will take the final one, final velocity, 8/5, minus initial, 4/5, and then we divide everything by 3. And of course, 8 minus 4/5, that's 4/5. 4/5 divided by 3, that's 4/15. So you get 4/15 as your acceleration, which is also your gradient, multiplied by t. Right, so that's the equation of B. We'll find the one for A once we find the speed. So let's proceed to answering part A first. I'll rub out this part so we have more space. Right here. Cool. So let's solve for the distance traveled by A and B at this instant. Well, we know this instant is when time equals 3. That's when B catches up to A. If you want to find the distance, we use the motion, the equation that we know of, right? Use the one that take advantage of the equation that you know of. So that's the equation, the second one. Because we know the speed, we know pretty much everything about the car B. So if you want to find the distance traveled, so distance traveled by both cars, because they should travel the same distance for them to pass each other again. Distance travel, as we know in the velocity time graph, all you need to find the area underneath the curve. So there's two ways of doing this to find the area underneath this curve. One, just use geometry. That's the rectangle right here. See this rectangle? And then add it with a triangle and you get the distance, or you can just integrate it. Really, it's up to you. I'm just gonna use the geometry quickly. So in this case, area of the rectangle is 3 multiplied by 4/5. So 4/5 plus 3 times 3 plus half times by your base. So that's also 3, and then times by the height. The height in this case is 8/5 minus 4/5. Okay, so that's the difference in height. We just do that, and then we can find the distance. Your answer should be 18/5, or that is also equals to 3.6 kilometers. Okay, so that's the distance traveled by both cars after 3 minutes. So 3.6 kilometers. And of course, we can use this information to help us solve for the speed of A. So find this missing information, right? What is VA? So we know the distance traveled is 3.6 kilometers. That means the area underneath the curve for the green line right here, so the equation for A, should be 3.6. So yeah, all you have to do is just do that, right? Once again, you can use geometry, you can use anti-diff. If you want to do it quickly, I'll show you how to go about it. So we take the area of this rectangle instead, so all the way up to 3, and then the area of this triangle. Well, we know the area of underneath this curve, we know the area of this rectangle is 16/5 multiplied by 3. And then the area of the triangle, once again, so that's half multiplied by the base, which is still 3, multiplied by the height. We don't know the height, but we know this point right here is VA. That's what we want to find, right? So we call it VA, final velocity of A, minus the initial velocity, which we do know, and that is 16/15. Okay, right there, and then we know the distance should be 3.6 because we just solved it, and then you need to solve for VA. In this case, guys, your final velocity should be 4/3 kilometer per minute. Or if you want to convert it back into kilometer per hour, multiply it by 60 or do the ratio, same thing again, and you should get 80 kilometer per hour, which we know is actually slower than the 96 kilometer per hour that car B was, right? And it makes sense. Car B has to end up being faster than A, or else B would never catch up with A. So this is how you would solve part A using the velocity time graph. Guys, once again, you can use your 4 physics formula because it is a constant acceleration question, so that's up to you. Right, and then now I'll proceed to do part B. So I've just pretty much copy pasted everything we just did over here. Let's do part B, which is to find the instant at which both are moving with the same speed. So technically, find the time when the velocity are the same. So pretty much this intersection between the two lines, right? So T1, that's what we'll call it. So if you want to find the intersection between the two lines, first of all, you need to know the equation of the motion for A. We're almost there, we just need to find the gradient. So we know that the speed of A as found in part A, right? So what do we find in part A? That the speed was 4/3 km per minute. So I'll just write that down. This is 4/3 km per minute. So you've got everything. You can find the missing information. If you want to do that, all you need to do is acceleration of A, car A, that is 4/3 minus 16/15. 16/15, divide everything by 3. Well, it's supposed to be 3 minus 0. And you should get 4/45, and well, but that's pretty much your gradient. Okay, so 4/45. Okay, so once you found the equation, guys, it's very simple to find the time when the velocities are the same or when the speed are the same. All you need to do is just equate the two equations together. So that's VBT equals to V equals to VAT. And if you do that, guys, you put inside your calculator, make them equal each other, you get T equals to 1.5 minutes, okay? 1.5 minutes, and that solves the first part of part B, and the second part, the distance between them at this time. So really, they just want you to find the distance of car A, find the distance of car B, and then what's the difference. If you want to do that quickly, again, on the calculator, distance of A, that is the antidiff. You can also do geometry, but I'm just going to use antidiff, a little bit of variety, I guess. So 1.5 to 0, or 0 to 1.5, and then the equation of A, or the equation of B, up to you, you can start whichever one first. I'll use A first. 16 on 15 plus 4 on 45t dt. And what you should get for this one, we know that A is actually higher than B, so really this one should be higher than the second one, which we're going to find. This is B. But if you times out your calculator, that is 1.7 kilometer. And then same thing here, we do the same for distance of B, or how far car B traveled in 1.5 minutes. So 1.5 to 0, and in the equation of B, so we're just finding the area underneath the curve, so chuck that in. And this one, guys, you should get 1.5 kilometer on your calculator, or you can do it by hand too, but it does take a while. Afterwards, guys, almost done. All you need to do is just take 1.7 minus 1.5 to find the difference, and you should get 0.2 kilometer, or you can put in meters, that is 200 meters difference. The difference in the distance between car A and car B after 1.5 minutes. Well, that's pretty much it for this video, guys. All I've done here is just use the velocity time graph to help to solve this question. But of course, like I said before, you can also use these formulas to help you. Or you can do both, like, you know, it's up to you really. But aside from that, guys, thank you for watching. Hopefully this video was useful in helping you solve this question. But aside from that, thanks for watching. Leave a thumbs up, and I'll see you in the next video.